There are a couple conditions that can happen when you aren't getting enough protein. One is called hypoproteinemia, and that's when you don't have enough protein in your plasma. So remember, the plasma is the liquid part of your blood, and that's in cases of extreme starvation, liver, kidney disease, or severe burns. So anytime you have these three conditions, you can have this disorder, right? So then this one, the way it's pronounced is kwashiorkor, and this is what we see children get that have a severe protein deficiency. So we see these in a lot of commercials of children in third world countries that show their distended abdomen, swollen abdomen, big belly, skinny arms and legs, and that's because they're not getting enough protein in their diets. So there are different agencies that are trying to give these children cereal that is beefed up with more protein and protein powder so that they can be a little bit more healthy, right? So the kids are still alive, they're not very healthy, and there are a lot of different organizations trying to help in that regard. So in order to make blood, first we need to make 400 billion platelets, 100 to 200 billion red blood cells, and 10 million white blood cells every day. So that's a lot of cells. Hematopoiesis is what this blood production process is called. So that's what we're talking about, just making blood in general, not the individual pieces of parts that we'll get into in a minute. You'll find, and you probably saw this, there are a lot of policies. There are a lot of poieses, so chemopoiesis, hematopoiesis, erythropoiesis, leukopoiesis. But when we're talking hematopoiesis, we're talking about the production of blood in general, especially its formed elements. So the yolk sac is going to be the first place that you make red blood cells. So to think about this, if you crack open an egg from a farm, sometimes you can see little blood spots in your egg because that was a fertilized egg. So it was already starting to make blood, if that's, an easier way for you to think about it. So that yolk starts making the red blood cells for you for the first time. After that, it goes to the bone marrow, the liver, the spleen, the thymus, and that's where your blood cells are going to come from. Your liver quits making blood when you're born, and the spleen remains involved with making the lymphocytes, but that's it. It doesn't make the other things after you're born. All formed elements, they trace their origin to a common type of hematopoietic stem cell in the bone marrow. All right, so moving on to erythrocytes, or our red blood cells. Site cell, erythro, red. They have two functions. They carry oxygen from the lungs out to your body everywhere that your tissues need oxygen. And while they're in those places in your body, they are picking up carbon dioxide and other wastes. And they're going to take that carbon dioxide back to the lungs. And they're going to take all the other wastes to the kidneys and liver, and those organs will take care of those wastes. So erythrocytes have a biconcave shape with a thick rim and a thin sunken-in center. So this is what it looks like. They do not have mitochondria, and they do not have a nucleus. They don't have their own DNA, so that means they cannot do protein synthesis, and they do not go through mitosis. So when these cells die, they are dead. They cannot replicate. So why are they shaped like this? This shape allows them to bend and twist and move, so they can get through small vessels. And if they did have a giant nucleus in the way, they wouldn't be able to get through the small spaces or through the vessels that they need to go through as easily. And inside the red blood cell is a molecule called hemoglobin, and it gets